Sesasai, Dr. Sesasai from NRSC, Deputy Director of NRSC, who has also come all the way from Hyderabad to join this particular program. Thank you very much, Dr. Sesasai, for joining. And we also have Dr. Shantanu Bhatpatkar. He's the Director of Earth Observation Systems from joining from ISRO headquarters, Bangalore. So I welcome you all for this program. Now we have a very short duration for this time. We are already late by 10 minutes. So I will go on to individual panelists and ask their opinion on certain points. Like, for example, let's start with Dr. Saibal Dasgupta-ji. How remote sensing and geospatial tools have benefited in mapping and monitoring, including the forest fire, for Indian forest resources, and what are the challenges and opportunities in bringing awareness to create an eco-friendly environment. So over to you, sir.
Thank you, Dr. Senthil, for giving this opportunity. It's a pleasure to be here with all of you. I know the time is a constraint, but I'll just take about 4 minutes in brief to explain how remote sensing and GIS technologies have helped in mapping and other forest resources work. Now, Forest Survey of India primarily takes up there are two primary core areas. One is the forest cover mapping of the country on a 2-year cycle. The other is doing the field inventory to assess the growing stock, the volume of timber available in the country. All these inputs are very important for the planning process in the Ministry of Environment, Forest and Climate Change, and the data collected from our field units actually go into the decision making processes of the ministry. It is also very important data for researchers, for academicians, for civil society organizations. They have access to this data. It's all online data, and a lot of work can be generated through the data which we provide. India, I would just like to mention here that India is probably the only country in the world which does this forest cover mapping on a 2-year cycle. It's an enormous task. We complete one cycle and our people do not get any rest, they start the next cycle. Over the years, the forest cover mapping, the technology has advanced. We earlier started doing this in 1987. The first report came out in 1987. We started from 86. We used the Landsat TM data at that time. Over the years, now we have improved our scale of interpretation. We have moved from visual to digital mode. And today we can map the entire country on 1:50,000 scale. And for us, the forest cover is any area above having 10% canopy density with 1 hectare in extent. But we have also moved further beyond with technological interventions, modernization. We can now go down up to 0.1 hectare in the ground because there are many small blocks, woodlots, scattered trees. There are trees along the roads and railway lines which also add to the biodiversity of the country. They also add to the green cover of the country. They also are storage of carbon. Carbon is a very important thing, which we all know that India's commitment to India's NDC 2030 that we have to increase our carbon dioxide equivalent to 2.53 gigatons more than what we are doing. And for that, one of the primary areas is to increase the afforestation in the country. So this organization primarily monitors the forest cover. Besides the forest cover and the inventory work which we are doing, we are also doing a lot of work on monitoring of the different plantations. One of the portals which we have developed is known as eGreen Watch, which basically monitors the plantations under the CAMPA funded projects. You all know about the CAMPA bill which has been passed recently. But this tool which we have developed with the help of NIC would also help in monitoring other centrally and state-sponsored schemes. So that's one of the things. The other thing which FSI has developed on its own is a decision support system by which the nodes we have given to a lot of users, about 1,000 users have been given the user password and the user ID. This is primarily to take a decision on whether a particular forest land is fit for diversion or not. Now, you all are aware of the number of forest conservation cases which comes for decision, Earlier it used to take a lot of time because the file used to go from, from the central government to the state government right up to the level of range officer. It used to take months and years, in fact. But with the decision support system, wherein we have put 21 layers, some of the layers from Indian Institute of Remote Sensing also, the biodiversity characterization, some of the layers from the Wildlife Institute of India, and our own layers, different like forest cover, forest type, the biodiversity characterization, the wildlife corridors, the tiger areas, and administrative boundaries, so on and so forth, have all been put into a GIS mode. So again, to help in giving a decision as to whether and of course there are different algorithms. I cannot go into details of what exactly, how the decision takes place, but you can easily come to a decision as to the fact whether this area is fit or not fit for diversion. So at least you get a first-hand information. Of course, everything depends on what is actually there on the field. But what I'm trying to say is that the remote sensing, the GIS tools are of huge help in taking active decisions, and it has reduced the time period. The other area which Dr. Senthil was mentioning was of forest fire. Forest fire FSI has been actually, again, we are thankful to NRC because we get the entire information from NRC's Earth Station, but we process it out here and then we send it to the State Forest Department. Now, from 2004 when we started it to 2017, there has been a huge change in the technology, the speed, and the accuracy of dissemination of these fire alerts to the Forest Department. Earlier, we used to just disseminate this information only once because the technology used to get only one pass from NRC. Today, through the MODIS, we get 4 passes every 6 hours. And then from this year onwards, we are using the SNPP VIIRS information also. So we're getting 2 more passes. So practically 6 passes a day. The information is filtered at FSI, value added, put in with the lat long, the district and administrative boundary, and right up to the beat level, whoever are registered, they get it within an hour. So that is the art of technology, or that is the the science behind it. How we have improved from 2004 to 2017 from 24 hours to now practically 1 hour, near real time. We are also into pre-fire alerts and burnt area assessment. So, and I just 30 seconds more I'll just take.
Please take
That of late we are using the very high resolution data. We've got through NRSC. We in fact thinking of taking more VHR data, especially the Cartosat 2, which has been launched. These are important for species identification because the data which we use, resource that data is not very good for species identification. We would like to use this for species identification, also for diversion cases, for identification of illegal mining if it's going on. There are lots of things. Even for cloud-free areas, sometimes a lot of clouds you don't get, so cloud-free area. So we have now established a very high-resolution lab with sub-meter data, and we're looking into these aspects of application. The future is very bright in these technologies. We would like also to. We are also working now on SAR data for biomass estimation along with SAC. We have a project with them. We are also looking into how we can sort of synergize the inventory data with the remote sensing data so that you have a wall map of the country where you just put your lat long and you get all the information right from forest cover to forest type to the growing stock to the biomass to the carbon content to the tiger corridors to the wildlife habitat, everything. So that is a future domain which we would like to work on. And the other thing was, of course, we would like to develop a mega geo portal of FSI, and of course link. The other thing is we would like to link with all this our organizations, such scientific organizations like we are in touch, obviously, with ISRS and NRSC, but more such coordination and synergy between the organization would be even helpful in dissemination of the methodologies or the applications of remote sensing GIS. Thank you very much.
Thank you very much, Dr. Daskotwaji. It was a very wonderful briefing about what all activities which are being taken up by FSI, and it's very heartening to listen to you, particularly saying India is one of the countries who is making every 2 years a cycle of the forest map, which is very important inventory analysis which has been taken. And we also, ISRO headquarters is also listening too. So, and there are many new sensors which are being lined up.
Yes.
I hope even the very high resolution data for species level identification will settle be met with the resources available within India. And of course, there is always opportunities to collect data from other sources also. So I'm sure there is lot potential activities jointly can be done with ISRO, as well as there are many academia, as you can see here, ISRS, Bharadasan University. I could see many of the videos where lots of students or future professionals are going to also get geared up for this activity in future. Thank you very much for your briefing. Now let's move on to Dr. Mathur. He's another one department or the institute which has been extensively using for a very complex problem of managing human and animal conflict and using all geospatial information and remote sensing. So I would like to probably ask your opinion, Dr. Mathurji, on how remote sensing and geospatial tools have benefited wildlife habitat planning and monitoring, and also what are the challenges and opportunities to bring awareness to minimize the human-animal conflict, which of course every now and then we keep reading in the newspapers. Probably you're the right person to give us some guidelines, please.
Thank you very much for inviting me. I will begin by narrating a little bit of institutional history. The institute was being set up in the mid-80s, and the two things that institute decided was that remote sensing and GIS application shall form the key part of the operations. And I had joined the institute as a very young scientist 30 years back and was assigned the responsibility of setting up of this facility. And obviously the first thing I did was to come to IRS. I joined one of your short programs to get an understanding. And then we had a real life challenge, which is I want to narrate a particular hydropower project in the state of Madhya Pradesh, the Narmada River Valley project. And the government had given sanction, and as things stood that a huge, about 40,000 hectares of prime forest land was getting submerged. And we were asked by the ministry to do an impact assessment. And we thought that for such a huge area, obviously the remote sensing application would be the first choice. And at that point of time, I now recall the IRS satellites were not in place. And we had to take recourse of the French satellite, the spot data, and what about 35 meter resolution or something. But we could then understand that how to characterize the habitat in a very rapid way and what a time series data can help. So that was our first foray in wildlife habitat planning, and also suggesting the mitigation part, because the dams, as the government had said, are going to come, and in the event of dam coming up, what measures would be required. So, and I also recall that we took almost 2 years to complete that project, and every time my director asked that when are you submitting the report?
Okay.
And why I'm narrating it, that see, for any institute to set up a lab, it takes time, and at that point of time it took almost 2 years for us to do the ground truthing and come back and do the validation and do corrections and so on. And then we had opportunity of collaborations. So we had a US Fish and Wildlife Service collaboration. And believe me when I say that every project we then thought was to have an application of RS and GIS. And in one of the project meetings, the scientists from US asked me that, Dr. Mathur, can you tell me how many projects are going to use RS and GIS? So I thought for a while, and then I said, I will not answer this question like this. You should ask me which project will not use.
Okay.
So see, I never forget saying, narrating that was the importance of using the power of the remote sensing GIS, and we have come a real long way from that. And nowadays, see, initially it was a glamour and a myth also. And if you ask anybody, he says, yes, we will create a special database. And everybody was vying with each other whether it will be a 30-layer database or a 40-layer database. But see, all things have now changed. So the technology is settled, the applications are there, and people are going more and more into that. So I can say with pride that with IRS help and with your professionals, many of you are still there. We had a wonderful opportunity of developing that science, and we have, for a very large purpose, I would say, met with those requirements. But as I say that, new requirements come. For example, we were asked very recently by the ministry that what is the impact of boulder collection and how sand mining is to be regulated. Because these areas, these mining, what now they we call as a riverbed material, so how much material has to be removed. And then we realized that can we use remote sensing? And when you ask me challenge, my first challenge was to come back again and to see how far the technology has moved. And we did realize that there was no ready-made answer, because now your colleagues and my colleagues said, now you have to use a 3D modeling, and you need to have investment of time, energy, and satellite, and so on. So these challenges do come up, and I do now realize that the very high resolution satellite data is the answer. So while you can solve other issues with the normal satellite data that you get, but here is a kind of a new challenge that we learn to use that. But I can see that it is a probable answer to the kind of things that what will be the level of harvest. See, there are the ecological side of it, which says that some bit of boulder collection and sand mining is fine, because that is a part of a natural process. You do get these boulders after the monsoon and sand mining accretion, but then the scale of which the mining is to be done, and that is the issue. So regulation is an issue. So now the question is, what should we allow? And that kind of an estimation has to be done using by very high resolution satellite data, and we will come back to people who are dealing with that. And lastly, and again importantly, is your question on human-wildlife conflict. See, this is an issue, top of the line, number one issue. No meeting of wildlife can take place without somebody referring that this is what the species and this is what the problem is. And now we are thinking that how best we can do that. We are using what we call as radio collars, and earlier they were radio, now they are satellite collars. And the whole game is hinging, how do you detect the presence of an animal? And when I say detect the presence of an animal, I am talking in first relation to a large animal like an elephant. That how do you find that the elephant is there and will move? And we do put our satellite collars, but satellite collars have their own limitation. And that is where we now, when you ask me, I read your letter, it says geospatial. So it's not just RSGIS that we are looking. IT is now going to form a very important. And fortunately in South Africa, they have now developed satellite collars which provide signals which can be picked up by a cell phone. And that is the kind of alert system they are trying to develop. That while you get the direction from the satellite, but the range officer on the ground can be alerted and say that this particular animal is 50 meters or 100 meters, and you can then warn the people over there. And lastly, I would say another area, because lots of people are getting killed by wild animals, but wild animals are also getting killed. And the case in point is that of elephant along the railway tracks. So huge amount of mortality taking place in West Bengal, in Orissa, in our own state of Uttarakhand. And that is where again we are looking at options, technological options. Can we have an ability to develop a sensor-based network which can pick up the seismic signals? Because when elephants move, there is a lot of seismicity which is generated, and if those things can be picked up through a sensor, then alerts can be issued. So we are right now working with a CSIR organization based in Chandigarh, looking at seismic signals coupled with acoustic signals and coupled with infrared signals. So as I understand, as we do those pilots, not one can provide that answer. You need to have the seismic and the acoustic and the infrared signal. So basically, a huge application of geospatial techniques is waiting to be understood and to be applied. And we look forward to such opportunities and collaborating with professionals who can help us in providing a real-time solution to these issues.
So thank you very much, sir, for your excellent narration of the various challenging tasks that the WII is taking up, and also it is always a pleasure for us to listen to an alumni of our institute giving new challenges for us also,
Yes.
what and how we should probably work towards solving some of the very challenging research which needs to be taken up. We are with you, sir, and I am sure we will further collaborate in all possible way and share our knowledge and experience to solve whatever best way we can sort out this.
Well,
Thank you,
very much
excellent.
for those kind words of assurance.
Sure, sir. Thank you.
you.
Now I would like to call upon Dr. Santanu, Director UOS. Dr. Santanu, are you on the line? He is joining virtual. Yes, Dr. Santanu, can you hear me? Dr. Santanu, can you hear me?
His mic is on.
Call him. Okay, I think you please arrange it by the time we'll go. Please call up. We will move on to Dr. MVR Sesasai. He's the Deputy Director of National Remote Sensing Center. Dr. Sesasai, there's lot research and as well as operational activities which are there at NRSC. I would like to just ask you a question like, can you please brief us how remote sensing and geospatial information have been benefited in various national projects like Fuzzle and CAPE and so on? And what are the challenges and opportunities of capacity building program to benefit working professionals and officials in various government ministries and line departments? So over to you, Dr. SSI.
Thank you very much for your invitation. And basically, I should say that our country is an agrarian country, and the government and the country wants the information on the agriculture. And in this context, the remote sensing has been able to provide the information with regard to the pre-harvest crop acreage and production estimates of some select major crops. And this information is useful for taking strategic decisions with regard to the export, import, or pricing policy, or public distribution system, and various other market intervention operations. Similarly, this technology is also being operationally used for a drought assessment, especially the agricultural drought assessment in major parts of the country. And this information is also will be provided on the prevalence, the severity, and the spatial extent of this agricultural drought that is occurring and having an impact on the total economy. And in addition to these things, sir, we are also using this for horticultural crop inventory, crop insurance, and various other studies. In agriculture, what happens is the efficient management of agriculture depends upon the efficient management of our natural resources. So in this regard, the land and water management plays a very important role. And using remote sensing data, land use land cover maps are being generated, especially those that are generated on 1:250,000 on a every season basis. They provide the information with regard to the net zone area, and such type of informations will be useful for resource allocation by the governments. And similarly, the land degradation and wastelands are also being monitored using the remote sensing techniques. And I should tell you here that a water resources information system has been generated, which along with the information on the soils, crops, and the land, etc., will be very much useful for the governments, and they are using this information in that particular manner. And in all these states, what I have to say is, all these endeavors, the state governments are also actively participating in it. And this information is not a static information. This is a very dynamic information which needs to be updated at regular periodicities. So regular periodicities means regular observations with the upcoming developments in the technology have to be assimilated, and these assimilated technologies have to be passed on to the through the technology diffusion processes to the states and to the various other stakeholders. In this context, ISRO conducts regular programs, specialized programs, customized training programs, and of course some in-house programs also it carries out. And especially very recently we have opened a facility, outreach facility, wherein the data will be provided, the methodologies will be provided, they will be mentored, and the stakeholders here, the target group is the students, the academia, the startups of the industries, so and also the professionals also we are going to kind of make these facilities available to them. So through these outreach facilities, we want to say that we want to take this technology to the doorsteps of their stakeholders and the users, so that they can get much more benefited and update the informations for what all that are required for the country from time to time. This is our thing, sir. Thank you.
Thank you, Dr. Sesasai. It was a good narration about what are the present activities which are going on. Thank you very much, Dr. Sesasai, for narrating the activities which are going on at NRSC, as well as the future challenges and readiness for doing the capacity building requirements of the country. Thank you very much. So I will now request Director EOS, Earth Observation Systems, Dr. Santanu from ISRO headquarters, to kindly give you a briefing on what are the pilot projects undertaken by government ministries and departments in jointly with ISRO post the geospatial meet which was conducted in 2015 for the applications in e-governance and resources management. What are the challenges and opportunities from the present and future Earth observation missions? As you have heard from some of our panelists that they are looking for high resolution data. So future missions to meet the National Development Program. So now this is over to you, Dr. Santanu. Dr. Santanu, we are not able to hear clearly. Can you be close to the mic?
Hearing to all the different presentations for a wide variety of applications in the remote sensing and geospatial technology almost for the past 2 to 3 hours. In India, as you know very well, that as far as the major driver for the remote sensing applications is concerned, we have in the past many years the applications which have been adopted by the stakeholder ministries and departments for the operational use, and now they are providing services from their premises. Uh, major change interactions. We are on a one-to-one basis. We are interacting with the ministries and jointly formulating the action plans, developing the tailor-made, customized applications and tools for them, and also the capacity building for specific applications. And of course, also we are insisting on the formulation of space technology cells in the various ministries. Now, in this scenario, we are now working almost on 160 projects across 58 ministries. Many of them you would have heard in the sessions. Let me highlight a few of them. Like we are working for the inventory of horticultural crops and also for identifying the suitable sites for the expansion. We have developed large number of mobile applications to deliver the advisory services to the farmers for crop management practices, soil health cards, crop diseases. Now, as far as the even the surface water body maps are concerned, it are being provided almost every fortnight to get the entire nationwide surface water map to understand the availability of water. And we have now also developed a lot of mobile applications for geotagging and collection of information. And many of the applications and flagship programs of Government of India are operationally utilizing it, like whether it is Mahatma Gandhi National Rural Employment Guarantee Act or talk about Department of Post for crop insurance. We have the Prime Minister's Awas Yojana, and many such applications are there which you have been hearing. But as far as continuity of the application is concerned, we have planned a large number of missions in future to provide the data continuity. The major requirement, the major challenge for all these applications are the special resolution. People want to generate the large scale maps and also the revisit and visit the area of interest. So maybe few of the missions which are planned in future, I can tell. Very soon we are going to have our resource at 3 city satellites, almost 20-meter resolution, with a wide swath of almost 900 kilometers. We are also going to provide the resource at 3 Pannel to give a 1.25-meter stereo imaging capability and to give the high resolution. We are going to launch a constellation of 3 satellites that is called HR-SAT, wherein 3 satellites will be launched together in a single mission. It is in the orbit. So almost every day, 1 meter data and almost 4 meter multispectral day-to-day basis. We are also planning the oceans at 3 satellites with the large number of bands. Then we also have the reset 1A continuity for the microwave data on the C band and various other atmospheric satellites and weather satellites for weather information. Thank you.
From our side was a bit of problem. Uh, okay, now we will move on to Dr. George Philip, senior scientist from Wadia Institute of Himalayan Geology. Wadia Institute is one of the very primary institutions to use the remote sensing and geospatial tools for various geological applications, particularly pertaining to Himalayas, which is a very challenging task. So I would like to request to brief for the students community in particular how the remote sensing geoinformatics help to understand the Himalayan geology and its ecosystem, and also what are the challenges in modeling very important geological events like earthquake, crustal deformation and so on, using the geoinformation technology like GNSS, IRNSS, seismometer, etc. Over to you, sir.
Thank you so much.
Keep
Good
the
evening
mic.
to
Mic.
good evening to everybody. On the eve of National Remote Sensing Day, It's an honor to say how remote sensing is being used in understanding the geology of Himalaya. And Himalaya, as you know, is the youngest restless mountain chain, and it is continuing to be restless. It is an abode of natural resources as well as natural hazards, and it is a frozen reserve of stored water as well as a home for many people. The high altitude and limited accessibility to reach every outcrop of our interest to visit, as well as the limited field seasons, the extreme variation in climate, weather, and also the inaccessibility makes Himalaya to be an ideal candidate so that we can use remote sensing, in the sense that you can bring the whole Himalayan terrain on your laptop, on your desktop, and to study. But when we do that one, we have seen that basically we try to address the problem of understanding the natural resources as well as to understand the natural hazards. When I say natural resources, first we try to understand the extent of Himalayan glaciers. And glaciers nowadays is a very hot topic. It is estimated that roughly 10,000 number of glaciers are spread over the Himalayan terrain. However, unfortunately, we are unable to have any clear detailed picture about these glaciers. Hardly we have studied less than 1% of glaciers, but this data, this technique offers a great opportunity to understand, particularly using high spatial resolution data, high spectral resolution data, to understand its extent. Besides that one, glaciers are being highly sensitive to climatic changes, their recession rate, and also in terms of advancing glaciers, surging glaciers. These are all important that we are trying to undertake. Similarly, in glacier terrain, there is an important issue like in the ablation zone regions, we see number of lakes. We call it as glacier moraine dammed lake or supraglacial lakes, and these are potential threats for any event like glacial lake outburst flood, which can happen in the downstream. So these need to be understood, particularly monitoring those glacial lakes, whether they are shrinking, whether they are enlarging their volume, or whether they are a threat for a future outburst, because these lakes are very precariously preserved. This is one of the issues we are trying to understand. Also the movement, like using technique like INSAR technique, we try to understand the velocity, the movement of glaciers. And besides that one, when we see the natural resources like surface water, we have got fairly good idea about the drainage network and how the rivers are spreading across. However, the major challenge in Himalaya is that how far we are able to understand the hill aquifers where maximum population is there. And it's a big challenge for the villagers and people who are living there to understand the availability of water in higher reaches. And also there is a need of understanding the springs. The Himalayan springs are so famous, at the same time there are springs which are drying, some of the springs are getting rejuvenated. These satellite data is immensely useful in locating, identifying, and perhaps rejuvenating some of the Himalayan springs, so that water is available in the higher reaches of Himalaya where population is also very high. And there are other areas we are trying to look into, particularly mapping dissimilar lithological units. Himalayan terrain, as I told earlier, is the youngest mountain chain. The rock units are highly complex, the structure is highly complex. Therefore, can we understand with a high level of confidence the geological details, the structural details? These are also we are attempting in our institute, particularly using high resolution data. And I don't have to tell much about the economic mineral resources available, because that is a separate issue. But let me come to the natural hazard, which we always say about Himalaya. When we say about natural hazards in Himalaya, first comes the landslides. Landslides are the frequent phenomena in Himalaya where we need to identify those vulnerable areas which are likely to have future landslides. In that sense, we need to identify active landslides and paleo landslides which can be reactivated at a later stage. We have done some studies even in collaboration with ISRO, we have done earlier also. Some atlases we have prepared, inventory has been made, but these are all on a smaller scale. We need to use higher spatial resolution data so that we can give a fair picture about a possible threat to the particularly the trunk routes and also the link routes and the villages. And besides this landslide hazard zonation, we also try to use the images to understand the study of landforms. When I say landforms, this is addressing basically to the paleo earthquakes. The earthquakes which has happened, you can say prehistorical earthquakes, which has got a large magnitude, and those areas can we identify. Remote sensing is the ideal tool with which we can identify tectonic landforms. Based on the study of tectonic landforms, we are able to say whether a large magnitude earthquake has visited that area in the past or not. If you are able to do so, if you are able to identify fault system generated because of paleo earthquakes, we can always delineate those areas for a future event, because in geology we say active faults. What is active fault? Active fault is that fault which is a cause of a future earthquake, or the other way if I say it's a scar of a past earthquake. So if you are able to identify those fault zones which are very useful for a long term prediction of earthquakes, because which is now earthquake prediction is a very tricky issue. So far we have not achieved for a very finer higher resolution, but long term prediction is quite possible, that we are able to identify those features, active faults, and delineate the area based upon the risk parameters. Now in Himalaya hardly we have got any such study carried out. So these are the areas which we are trying to understand, and apart from that crustal movements, like for example Dehradun, the place we are sitting is sub-Himalayan region, and we are almost in the active tectonic front, and we are able to see, it is necessary that we need to identify crustal movements, any locked faults, so that we can give much information regarding the future earthquakes. These are some of the areas we are trying to address using remote sensing data, but at the same time there are challenges in the sense that how far we are able to with high confidence level, how far we are able to map dissimilar lithological units, structural units, landforms. Always in Himalaya we face a problem of vegetation. Vegetation become a major handicap. Can we overcome that one? It is possible in higher Himalayan region which is devoid of vegetation. We are able to do a we can prepare a reasonably good map, but whereas vegetation cover is there, we need to opt for technologies like LiDAR and things of that sort. And microwaves area also we are trying to address, particularly in glaciated area as I was sharing. Now we as a whole, sir, I can say that this, as I said earlier, Himalaya is an ideal candidate for using remote sensing technology, and we feel that with the frequency of number of satellites coming with high spectral resolution, high radiometric resolution, we will be able to map not only our natural resources, but able to monitor and mitigate natural hazards also. Thank you.
Thank you very much, Dr. George Philippe. It was a very good narration about the challenges in understanding various geological issues related to earthquakes, and how the technologies, including remote sensing, could help to a greater extent to understand the geology of Himalayas, where actually we are facing very frequent earthquakes. Again, even recently also, it has been declared as a very.
We are in the seismic zone 4
Yes,
and 5.
exactly. So I hope the research will lead to a comfort zone for the people who are living in this area. So I'm now trying to see whether Dr. Krishna Mogan from IIT Bombay, whether he is able to join us. Can you hear us, Dr. Mohan? Dr. Mohan? Okay, I think there's since beginning there's some issues there. So I is available. Professor Mohan, can you hear me? So meanwhile, when the connections are getting tried, I have some message which I received from Director ISAC, Dr. Milesoma Anadre, who had been the pioneering work done for Chandrayaan and Mars missions. He had conveyed his message to the students and academic community as follows. Indian student community can play a very meaningful role to take India's remote sensing efforts to reach different segments of the society depending upon society's needs and requirements. I anticipate very active participative contribution by the students community through crowdsourcing for various applications including disaster monitoring. They are the potential candidates for capacity building for innovative applications. Knowing resources, current practices and applications will certainly inspire them, align themselves in this journey. Best wishes for success of this program. So this is a message which I could receive from Dr. Anand Rai. So I think we are in PLN Raju joins. It's not getting connected. Okay, I think for want of time, probably we will close the panel discussion. It has been a great pleasure to have you all here and who had spared your time as well as an excellent ideas and thoughts which had really now come to various faculty over here as well as the students community who have been connected to this. And I also thank Dr. Santanu for sparing your time and be available for this particular panel session. And it's very unfortunate that we could not get connected with the two other virtual panelists, Dr. B. Krishnamohan from IIT Bombay and also our Dr. PLN Raju, Director NESAC. So with this, I think I will hand over the floor to the organizer, before which it's my great pleasure to give a small memento to all the panelists who have come all the way and give this excellent time for sharing their experience as well as thoughts for the future activities to come. So this is incidentally our main buildings for some kind of incoordination.
Thank you, sir.
Thank you very much, sir.
I think I'll come this way.
Thank you very much.
so much.
I think I already have it. I already have it.
Mr. Sasai for coming all the way. Thank you very much for your time as well.
I think I already have it.
No issue.
Not switched off.
Yeah, take this. You take this.
Good evening, all panelists, and also my participants distributed all across the country. First of all, before I start formal vote of thanks, I have a pleasure in announcing that we are very close to 1 lakh participants which are connected. Right? So that is a good number. Um, so on behalf of ISRS, Indian Society of Remote Sensing, I would like to express my sincere thankfulness to each and everyone who are directly or indirectly contributed to make this national workshop a success. First of all, I express my sincere gratitude to Dr. A.S. Kiran Kumar, Chairman, Department of Space, and Secretary, Department of Space, and Chairman, Indian Space Research Organization, for his keen interest, encouragement, and extending all support to organize this workshop. I am grateful to Dr. Shailesh Nayak, former Secretary MOES and President Indian Society of Remote Sensing, for his invaluable guidance and unflinching support at every stage of planning and organization of this workshop. I express my special thanks to Dr. A. Senthil Kumar, Director IARS, who has been instrumental in conceptualization, planning, and successful organization of this event. I am thankful to Dr. Y.V.N. Krishnamurthy, Director NRSC, Dr. Tapan Mishra, Director Space Application Center, Dr. P.G. Divakar, Scientific Secretary, ISRO, Shri Pilan Raju, Director NESAC, for offering guidance and all required support to organize this event. I sincerely thank Director Deku and his team, Mr. Sambhav, for their cooperation and support in recording and preparation of talks so nicely. I am also grateful to Dr. V.B. Mathur, Director, Wildlife Institute of India, Dr. Seval Das Gupta, Director, Journal, Forest Survey of India, for accepting our invitation and participating by sharing their thoughts and experience in live panel discussion. I thank Dr. M.V.R. Seshasai, Deputy Director, NRSC, for traveling from Hyderabad and participating in the panel discussion and sharing experiences. I would like to thank Dr. Shantanu Bhadavadekar, Director, EOS, ISRO Headquarters, and Director NESAC, for joining in the panel discussion through virtual link and sharing ideas and enlightening the participants on the theme. We are thankful to Dr. Udayaraj, Chief General Manager, NRSC, Dr. S.K. Shrivastava, Group Director, IARS, Dr. Shashikant Sharma, Group Head, SAC, and Team Bhuvan, consisting of Dr. Vinod Botle, Group Director, Dr. Giri Babu, Ms. Vijay Bhanu, and Mr. Arul Raj, for their time and efforts in preparing demonstration. I am extremely thankful to my colleague, Dr. Hiten Padalia, who is Treasurer of Indian Society of Remote Sensing, for providing wholehearted support in organizing this event meticulously since its conceptualization.
Dr. George.
Yeah, I'm also thankful to Dr. George Philip, who is, I think he has helped us in many occasions, and I would like to thank him from the bottom of my heart for coming to IARS and especially providing his valuable thoughts. I would also like to thank IARS DLP team, which is duly acknowledged for their valuable support. ISRS Executive Council is gratefully thankful to for concurring the organization of this mega event. ISRS Headquarters Technical Team is thanked for hosting the program on ISRO website. The local chapter of ISRS, DLP coordinators and coordinators of the workshop at academic institutions, central and state department, ministries are thanked for showing keen interest in the program and witnessing its proceedings today. Faculty members of Geoinformatics Department are thanked for their support. Director Office, CMD, ISRS Secretariat are thanked for support. We thank each and every participant of this workshop who have attended this workshop from different parts of the country. Thank you very much for your kind attention and my greetings for the Remote Sensing Day. Thank you very much.